All right, students, last part that we want to talk about is series, and series is just simply the sum of a sequence. So a sequence could be, for example, 2, 5, 8, 11, 14, so on and so forth. A series is the same thing, but when you add the terms together. So series, sequence. And in order to make sure that we write series in a kind of a smaller format, we use what they call summation notation. So this symbol that you see here, that is a summation symbol. It is the Greek letter sigma. It's the capital sigma. So that's the capital one. It came out years later, but there's also, for example, this is a sigma if it occurs in the middle of a word, and then this is sigma if it occurs at the end of the word. So anyway, different ways in which you get sigma that come up, and that's these come up in statistics. Summation, comes up in statistics as well, but right now we're going to see it here. And what summation means is we add up all the terms defined by the beginning up to the end term of the certain rule. Okay, so within this example, it says, and I apologize, I used interchangeably I and N in these scenarios, so please don't focus on that too much. I didn't go back and change the notes in this situation, but it says we're going to begin with I equals 2 and we'll end with 5. And this is our rule. So what we do is we start by plugging in 2, and 3 times 2 is 6 plus 1 is 7. Plus, then we plug in 3. 3 times 3 is 9 plus 1 is 10. Then we plug in 4. 3 times 4 is 12 plus 1 is 13. And then finally, 3 times 5 is 15 plus 1 is 16. So this was for I equals 2, 3, 4, 5. So we started at 2 and we ended at 5. So that's the expansion. So what you need to understand is that this is the same thing as that. Okay? If you look at the next one, it says we start with 1 and we go to 3. So if you plug 1 in, we get 2 to the 0, which is 1, times 3 is 3. So we start with 3 plus, now we're going to plug in 2. 2 minus 1 is 1, 2 to the 1 is 2, times 3 is 6. Then we plug in 3. 3 minus 1 is 2, 2 squared is 4, times 3 is 12. And that's our summation. The next one, we start with 1 and we go to 100. You plug in 1 and you get 2 minus 5 is negative 3. Plug in 2. 2 times 5 is 10. And 2 minus 10 is negative 8. So I can write minus 8. You plug in 3. 5 times 3 is 15. 2 minus 15 is negative 13. So on and so forth. You don't have to do this all the way. You don't have to list all 100 terms. You can simply just write it as plus, and then the 100th term, we get 2 minus 500 would be negative 498. So that is how we write this. Generally customary to write for sure the first 3 terms and then the last term if you have a lot of them. So here's 10 of them. So 1/2 to the 0 would be 1 plus, and then if I plug in 2, 1/2 to the 1 would be 1/2. Then I have, if I plug in 3, 1/2 squared is 1/4, so on and so forth. And if I plug in 10, I get 1/2 to the ninth power, or 1 to the ninth is 1, you'd have 2 to the ninth in the denominator. So that would be that summation. So summations express series in short ways. How do we add up partial sums of arithmetic series? So you're going to add these up. So in this example, what we want to do is we want to take, let's just expand this. If you plug in 1, we get 1 plus 3 is 4. And if you plug in 2, you get 7. Plug in 3, you get 10. All the way up to your 20th term, that'll be 3 times 20 is 60 plus 1 is 61. So the way that we add these up is the sum of the first n terms of arithmetic sequence is equal to the number of terms you have times the first term plus the last term divided by 2. So the sum of the first 20 terms is equal to how many terms? 20 times the first term, which is 4. The last term is 61. We divide that by 2. 20 divided by 2 is 10 times 65. It adds up to 650. Look at how quickly we added all of these terms. It's actually pretty efficient. The next one, let's just write some of them out. So if you plug in 1, you get 96. Plug in 2, and you get 92. Plug in 3, you get 88, so on and so forth. And if we plug in 15, you would get 100 minus 60, which is 40. So the sum of the first 15 terms is equal to the number of terms, which is 15, times the first term plus the last term divided by 2. Take out my calculator. 15 times 96 plus 40 divided by 2. And we get 1,020. So easier than writing them all out and adding them up manually. You can imagine right now we're just using 15. If we had 150 terms, that would be even more ridiculous. So in this situation, we're going to add these up. The sum of the first n terms, we don't know n, is equal to n times the first term plus the last term divided by 2. We can figure out n. Figuring out n should not be too bad because we can do this. 58 is equal to, I'm going to use this formula, a sub n is equal to a sub 1 plus the difference times n minus 1. Look at how I can fill all these pieces in. Negative 8. The difference, it looks like, is 3 times n minus 1. That will allow me to solve for n. So I get 66 is equal to 3 times n minus 1. Or 22 is equal to n minus 1. Or 23 is equal to n. So the sum of the first 23 terms is 23 times negative 8 plus 50. 8 divided by 2. Take out the calculator. 23 times negative 8 plus 58 is 50. And we divide by 2. And we get 575. Again, in this scenario, we don't know how many terms we have. But we know the first term and we know the last term. So if I would like to figure out the term, I'd take 882, set it equal to the first term, plus the difference times n minus 1. Or 873, if we subtract that 9, is equal to 9 times n minus 1. I'll take 873, I'll divide it by 9, and I get 97. So 98 is equal to n. So the sum of the first 98 terms is equal to 98 times 9 plus 882, and we divide by 2. 98 times 9 plus 882, we divide by 2. 43,659. What if it's a geometric series? Say in this situation, you were adding up the first 9 terms. Let's see what it looks like. You have 1/2 to the 0, which would be 1. And if you plug in 2, you would get 1/2. Plug in 3, you get 1/4. All the way up until you do 9 terms. 9 minus 1 is 8, so 1/2 to the 8th. So we need to be able to do the partial sum of a geometric series. Here is that formula. The formula for the sum of the first n terms of a geometric series is the first term times a fraction. The fraction is 1 minus your ratio to the nth power over 1 minus the ratio. And so you can see in this scenario that the sum of the first 9 terms is the first term, which is 1, times 1 minus, what is the ratio? Each time you're multiplying by 1/2. And we're going to raise that to the 9th power, divided by 1 minus 1/2. Now, all we need to do is just plug that into our calculator correctly. I'll just show you a way in which I choose to work through this. 1 time, so we can leave the 1 alone. So I have 1 minus 1/2 to the 9th power over 1 minus 1/2 is 1/2. And dividing by 1/2 is the same thing as multiplying by 2. So 2 times 1 minus 1/2 raised to the 9th power. So that's what I'm going to plug in. That will be a little bit easier. 2 parentheses, 1 minus parentheses 1 divided by 2 raised to the 9th power. And you can see that I get 1.99609375. Instead of writing that decimal down, wouldn't it be nice if we had a fraction? Sure enough, press the math key, and if you just hit number 1, convert to fraction, it will tell you that it's 511 over 256. Some of you have never known that key before. There it is. All right, let's expand this out a little bit. We have our first 6 terms. If you plug in 1, you get 2/3 to the 0, which is 1 times 6 is 6. Your second term, if you plugged in 2, 2/3 to the 1 is 2/3 times 6 is 4. And notice that for this formula, you don't need to know the last term. The sum of the first 6 terms is equal to your first term times 1 minus your ratio, which is 2/3, raised to the 6th over 1 minus 2/3. Well, what is 1 minus 2/3? 1 minus 2/3 is 1/3. And divided by 1/3 is the same as multiplying by 3. So that makes it a lot easier to plug into your calculator. 18 times 1 minus 2 over 3 raised to the 6th power. Again, I'll hit math and convert to fraction, and I should get a nice fraction here. 1330 over 81. So this is my favorite part. What if we have, an infinite number of terms? For example, 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 plus ... all the way to an infinite set. What does that add up to? Some of you have thought about this before. And 1/2 plus 1/4 is 3/4. Plus an 1/8 is 7/8. Plus a 16th is 15/16. Plus a 32nd is 31/32. Plus a 64th is 63 over 64. Notice how close that number is getting to 1. It turns out that sum is 1. The sum of an infinite geometric series is extremely easy to calculate. You simply take the first term and you divide it by 1 minus the ratio. But this important key, the ratio, the absolute value of it must be less than 1. Your ratio must be smaller than 1. So we'll write this out. We're starting with, if you plug in 1, you get 1. Plus, and you plug in 2, you get a half, and a fourth, and an eighth. Notice your ratio is 1/2, so you're just multiplying by a half each time. 16th, so on and so forth. So we want to add that guy up. Well, the sum of that, you can see how you're going to infinity. The sum is going to be the first term divided by 1 minus the ratio. The ratio is a half. I get 1 over a half, and 1 divided by a half is 2. That's what it adds up to. In this situation, you can see that your ratio is 2/3. Your first term, if you plug in 1, you would get 6 times 1, which would be 6. So a sub 1 is 6. So the sum is equal to your first term divided by 1 minus your ratio. We have 6 over 1/3, or 6 times 3 is 18 is what this adds up to. Next one, they don't tell us our ratio, but our first term is 12. It appears our ratio is 1/3. So the sum of this number of terms is going to be equal to 12 divided by 1 minus a third, or 12 divided by 2/3. I don't like to divide. I like to multiply by the reciprocal. So I'm going to multiply by 3/2. When I do that, again, I get 18. This one, if you look, it appears that the ratio is equal to 2. So therefore, we can't use this rule. And just think about what you would be adding up here. 3 plus 6 plus 12. The next one would be 24, then 48, then 96. Just think if you continue to add these, can you predict what it would add to? Sure enough, it adds to infinity. Only if the ratio is less than 1 does this do what we call converge to a specific number. If the ratio is greater than 1, then weird things happen. It may go to infinity, it may go to negative infinity, or it may go to neither. And figuring that out is a bigger question that especially gets addressed in Calculus 2. So there you have it, folks. Series, learn something new. Thanks for a great semester. Later.